Hello everyone, in this video I'll be explaining the problem WEC-REC. So this was asked in Codechef contest starter 238. So let's read out the problem. WEC NITK is conducting a recruitment contest for student of batch 29. So there are n participant number from 1 and the participant I scores A of I in the contest. So WEC uses a weird ranking system called K clustering. All students with the same score form a cluster. Okay, the highest score cluster gets rank 1, the next highest score cluster gets rank 2, and so on. So only candidates belonging to top K rank cluster are eligible to be selected for the next round. Okay, so further, due to logistical constraint, at most X candidates can be selected. Got it. So determine the maximum number of candidates who can be selected for the second round. Okay, so it's not a difficult problem. So yeah, it's easy only. We have test cases, and for every test case we have three integers n, x, and k, and in the next line of each test case we have n space separate integer, basically the score of the participants. Okay, so they've given some of the examples, three examples they've given. So let's understand one by one. So we are dealing with the second problem, and problem name is WEC REC. Okay, so the second problem. So in the problem, what they're saying is there are n participants, and they are numbered from 1 to n. Okay, these participants are from NITK, basically NITK Karnataka, Surathkal also you can say. So and yeah, there are n participants, and they are from 29th batch. So these are not that important. So okay, so what they've said is they are participating in a contest, and each participant scores A of I score, right? They score A of I score in the contest, and this WEC people, they have a weird ranking system wherein they are choosing top K cluster score. Okay, which means the let's say there are two students who have scored 80 score, and there is one more student who has scored 70, and then there is one more student who has scored 60. So now these two students will be in a cluster, they will be considered as one cluster. So here 80 score there are two students, 70 score there are one student, 60 score there are one student. So now we have three clusters. It's like group of people scoring having the same score. Okay, and in the question they have said you have to choose top X clusters, I guess, sorry, top K clusters. Okay, we need to choose top K clusters. Okay, and there is also one constraint that there is logistic constraint, right? Which means, let's say in this example, if I see, if you take top two clusters, so the number of students that you'll be getting is 3, right? Now what if they have only requirement of 2 students, which means like whatever means of transport they're using, so in that only there are only two seats, so they can't take all the 3 students, right? They'll have to take the 2 students only. They have to somehow remove one student. Okay, so this is the problem statement. Now they're saying we need to find out what is the maximum number of students we can carry to the next round. Okay, so I think problem statement you have understood. Basically let's go to example and see. So we have n as 8, x as 4, k as 2. Okay, and the scores are 80, 100, 90, 100, 100, 80, 90, 80. So yeah, there are basically 8 students. Okay, and the constraint is they can carry at max 4 students, not more than that, and we need to choose top 2 this thing, top 2 clusters. Okay, so now let's try to form a cluster. Let's take the students scoring 100. Okay, how many are there? 3 are there, I guess. 1, 2, 3. So we have 3. Let's say now 90. So how many are there? 1, 2. We have 2. Now let's take 80. How many are there? 1, 2, 3 are there again. So these are 3 clusters we have. 3 clusters. Now what they've asked is we need to choose top 2 clusters. So top 2 cluster, if you see here, it is these 2, because 100 is more maximum, then comes 90, then comes 80. So we have these 2 as top cluster. So in this case, how many students are there now? There are 3 plus 2, which is 5 students. Okay, we have 5 students, but the logistic constraint is 4. Like we need to choose only 4. So now since there are 5 students, but our seat is only 4. Okay, so in that case only 4 will be moving to the next round, right? So now I think we have understood, like there are logical constraints based on that. So that's the reason we are not able to carry all 5 students. We'll have to skip 1 student, so we will be carrying at max 4. Let's try to understand the second example. We have n as 5, x as 5, and then k as 1, and scores are 10, 20, 30, 40, 50. Okay. Now in this case, if we try to make the clusters, we have 51, 40 also 1, 30 also 1, 20 also 1, and then 10 also 1. These are top. I am doing it in a decreasing order, and this can be done in a map data structure. I'll be storing in a map data structure, right? So here what is happening is, okay, they have said you need to choose 1 cluster. Okay, top 1 cluster. So top cluster is basically this here, right? This is the top cluster. So in this case, we have how many students? We have 1 student. Okay, we have just 1 student, and their logistic requirements are we can carry up to 5 students. But since in the question they've said you need to choose top 1 cluster, in that only 1 student are there, but at max you can carry 5 students. Since you have less students, you will be carrying less students only, right? So in this case, your answer is 1. Your answer is 1. So whatever problem you will be doing, right? So what you need to do is you need to store in a map data structure, and like how many clusters they will be saying. So you need to choose those many clusters, and you need to return minimum of the calculated value, whatever sum you have, and whatever x they've said. So once you do this, we'll be able to solve the problem. So I think you have understood. Let's try to code it up. We have test cases. For every test case we have n, x and k in the first line. Okay, now for every test case we have integer, we have scores basically. So we'll take one map and we'll be sorting this in a decreasing order. okay, or you can call these clusters. Now we'll be taking each participant score. Okay, we'll take score. Now in clusters we need to store the score. So here what is having is we'll be having clusters and key as cluster and value as number of students in a cluster. Now as I said, we need to score the we need to choose the top clusters. Okay. So for that I'll be running a loop. Let's take count less than k count plus plus, right? Okay, and I'll be choosing here students. These students are initially 0. It's like these are the number of students that will be moving to the next round, and we need to iterate in a map. So I'll take one iterator. It will be clusters dot begin. I'll take one more variable as length, which is basically the cluster's size, like how many clusters we've got, and I'll put this as minimum of k comma length. The reason is, let's say they have said 5 clusters, but like they have told you need to choose top 5 clusters, but you have just 3 clusters, right? So this may be the case. So in that case we need to use only top 3, right? So that's the reason. Now your students is going to be added with iterator of second, which is like number of students in top 2 cluster. Okay, now when you're coming out of the loop, you may have more students in top k clusters than the required. Required is basically x. I said in the question, this is x. So what you need to do is you need to print minimum of x comma students. Let's try to run it. It's running fine. Let's try to submit. So yeah, it got accepted and beats yeah, the score is 100. So I think you guys have understood the problem statement and the solution as well. Now let's try to analyze the time complexity. So if you try to analyze the time complexity, so in the code if you see we are using one for loop. This is for input only. This doesn't matter. This is the thing where it matters. So the time complexity is going to be O of minimum of you can think of cluster size, let me call length only, comma k, top k clusters, right? Which is basically linear. And space complexity is also O of the cluster, which is basically, let me call it as length, okay, which is also linear. Like yeah, this is time and space complexity. Both are linear only, because if you see here, one for loop we have, and then we are using a map data structure in order to store the clusters. So yeah, thank you guys for watching the video.